Um, so yeah, yeah, welcome everyone to our, I guess, February meeting for the Optics PR Interest Group. So yeah, this is part of our year-long series on research-based assessments, and yeah, this is I think our first time we're actually going to be talking about an attitudinal inventory, so it's pretty cool. And so yeah, we'll be talking about the Colorado Learning Attitudes About Science Survey. I guess it's CLAS, right? Not class. Is
I've
that what they
heard
say?
both
Yeah, yeah, me too.
from
Okay, we'll call
Colorado
yeah.
people, so I don't
Yeah,
know what the answer is.
yeah. Well, I guess I'll call it CLAS and then maybe correct it later on. So yeah, and yeah, again, we've got a couple more events in the series that you should be note of. Yeah, March we'll have one on back to concept inventories about direct. And then in April, we'll be, I think, hearing from our own Krista Wood, hopefully, on the iStar, which I'm not familiar with, so I'm looking forward to that. And then plans are afoot for May, so stay tuned. Um, and then yeah, you can find more information on the Optics website, by the QR code. And yeah, just to kind of give you sort of an agenda for the presentation, we'll start with Leon Su. We might hear some additional data after Leon's presentation from our own Kareem Diff from Santa Fe College. And yeah, we'll always try to leave enough time for questions and discussion. And there'll be like an evaluation just about the workshop. Yeah, which many of you are probably familiar with. There'll be like a survey. Um, so yeah, I'll go ahead and stop sharing my screen. And yeah, take it away, Leon.
Okay, thanks. Before we get started, would it be okay if we just went around and did brief introductions, just so everyone knows who's here? I can start. My name's Leon Shi. I'm currently teaching at Santa Rosa Junior College, which is a two-year college about an hour's drive north of the Bay Area in California. Chris, do you want to go next?
Sure. Hi, everyone. Chris Louie. I'm Director for Optics, working under the American Association of Physics Teachers. And before this, I did teach at a two-year college as a full-time faculty member.
Okay.
Brian, do you want to go next? I'm just kind of going on the screen, so keep moving.
Sure. I'm Brian Stanley. I'm a faculty member at Lansing Community College, where I teach intro physics as well as some integrative science courses as well.
Kareem?
I'm
Yeah.
Kareem Diff. I teach at Santa Fe College in Gainesville, Florida, and I'm also a member of Optics.
Anthony?
Yeah, Anthony Squadro, also yeah, help out with optics interest group or PR interest group, and I teach in downtown Chicago at Harold Washington College.
Tony?
Yeah, Tony Musumba. I teach physics at Riverside City College. Yeah, thank you.
Okay. Bogdan?
Hi, I'm Bogdan Lu. I teach physics at University of Cincinnati Blue Ash College.
Okay. Michael, would you like to introduce yourself?
Yeah, I've stepped away from the.
Okay, that's all right. We can come back during discussion. All right, so let me go ahead and share my screen here. Let me start that and then do this. Okay, does that look okay?
Yep.
All right, so as a prelude, let me just talk about what my perspective is and sort of what I'm doing here. My experience with this, so I am not one of the people who developed this survey, or I would not be considered an expert on this, but here's kind of where I am coming from, which is before I came to Santa Rosa Junior College, I did work at the University of Minnesota, and I was working in an education-related unit. It's a long story, so I'm just going to say that part. And I was doing some physics education research. My main teaching responsibility at the time, it was a physics class that started out as a general education class. And a couple of years after I started teaching the main audience became pre-service elementary teachers, mostly because I was in the education-related unit. And while doing this, I got really interested in student attitudes and beliefs about physics and learning physics, because these were students who were going to go and become elementary teachers and influence our children. And I definitely didn't want them to have any negative attitudes about physics, or at least I wanted to minimize that. So that's why I got interested in studying that. And around that time, the class survey, or CLAS, came out, and so I started using that. In terms of what is it, so as Anthony kind of mentioned, is it the class or is it the CLAS? Personally, I've heard folks from Colorado uh, say both things. So I don't really know which one it's called. So it's up to you. You can pick which one sounds better to you. But it stands for the Colorado Learning Attitudes About Science Survey. What does it do? It measures students' self-reported beliefs about physics and the learning of physics, and it compares those to what experts believe. Experts meaning a lot of faculty members and advanced grad students that the designers interviewed about these questions to kind of get a consensus idea of what sort of the expert and novice view is. The survey itself is 42 items. So they're just statements, and we'll have a look at some of those statements. And the respondents agree whether they agree or disagree with these. It's actually a 5-point Likert scale. So their choices would be strongly agree, neutral, disagree, or strongly disagree. And this survey was developed by the Physics Education Group at the University of Colorado Boulder in the early 2000s. It was published in Physical Review in early 2006. In terms of the development of this survey, a lot of it was based on similar assessments that had been created previously. So these three that I have listed here, the Maryland Physics Expectation Survey, the Views About Sciences Survey, the Epistemological Beliefs Assessment for Physical Sciences. These were the types of things that the designers at Colorado drew from. So many of the statements look similar or are identical to items from these. In the paper where they presented this, I think it's a really nicely written paper. They talk about the stages that they went through to create this. And so that involved just creating the statements, drawing from previous surveys, similar surveys, and also from their own imaginations. There was a stage where they would present the statements to interviews and interview those students. And the idea was to make sure that as many students as possible would interpret the statements accurately. Because when you give a survey, you want to make sure that your respondents are interpreting it the way that you think that they should. That makes the results more reliable. At the same time, they were surveying experts to find sort of what the consensus expert response is, whether experts, meaning physics faculty, would agree or disagree with these statements. And one thing that was kind of a big deal about the design was this last thing, a statistical factor analysis to find coherent categories. Because in previous surveys, like the three that I have there, those were all developed sort of in the mid to late 1990s. Generally, what people would do would be they would kind of decide on what kind of dimensions they wanted to survey students on. For example, how strongly did students believe that physics was connected to the real world? Or how strongly did they believe that physics was a process of sort of sense making rather than memorizing equations? They would write some statements that went along with those categories that they had sort of decided that they wanted to survey, and then they would give the surveys, and then the surveys would be scored according to whether students are agreed or disagreed with the statements that went along with a particular category. And so that's kind of what people did at the time. This thing that Colorado did was new in the sense that they kind of went in with some idea about, okay, so we think that this is kind of a dimension along which these statements align, but they didn't end with that. They also used a factor analysis with thousands of responses that students had to try to see what statements correlated. On what statements did students' responses correlate? And they used that in conjunction with their a priori thoughts to determine what statements went together. And once they did that statistical analysis to find sort of what statements went together, they looked at those statements that went together and then tried to determine a category name based on looking at those statements and saying, oh, these statements all seem to align with this category. So that was really kind of a new thing. And that was one of the things that I really enjoyed about seeing the development of this. And now, that was back in 2006. That's kind of a method that many other designers of surveys have now adopted, but it was kind of a new thing to me, and I think it was one of the first times that had been used. So that was a kind of a big deal. I should say, feel free to break in at any time with questions or comments. So what were these categories that they came up with? The names that they assigned to the categories were these 8. So there's a bunch of statements about personal interest, real world connection. There were 3 categories or groupings of correlated responses that they thought correlated with problem solving, either sort of problem solving in a general sense, students' confidence at problem solving, or their sophistication at problem solving. There is a thing about sense making and effort. So we'll take a look at those questions. To what extent do students think the learning physics is about making sense of things? To what extent do they think that if they put effort into learning physics, that it will be worth their while? And then a couple of categories to do with conceptual understanding, whether sort of to what extent understanding concepts is important in learning physics as opposed to, let's say, just memorizing black box formulas to be used.
Leon, just
Yeah.
I believe Anthony had a question.
Yeah, go ahead. I can't be, but yeah, go ahead.
Oh, okay. I was typing it in chat just so I don't forget. I've been kind of curious. Like, is there any like value in like the older instruments? Like now that the class is out, like do these kind of like newer instruments just basically like replace the older ones? And like, there's not. I guess I've seen the MPEX, but I haven't really thought about it for a while. I don't need an answer now, but just maybe at some point in time.
Yeah, so I would say that all of these surveys, they're not really identical. They do, although there's a lot of overlap, they do have, they are different in some ways. They address slightly different views about science or dimensions along which you might want to measure students' beliefs. So, although I would say the class sort of has the most robust sort of research and validity and reliability stuff done behind it, it doesn't mean that the other ones aren't of any value. Those do have a bunch of research behind it to make sure that the questions are interpreted correctly, that there's sort of a consensus expert response, things like that. So I would say definitely you want to look at all of them and decide which one sort of aligns best with what you want to look at.
Cool. Thank you.
So in terms of these categories, I thought it would be useful to look at the questions or the statements that go along with each of them. So here are the ones that go along with the category that they looked at these statements and they said, well, personal interest kind of describes this group of statements. So I'll give you a minute or two to read them. And the responses that they came up with through surveying experienced physicists that were decided on as the quote unquote expert responses are these. There was enough consensus on these that they thought, okay, so if students agree with these statements, then they have a more expert-like attitude. Okay? Now, of course, one can always disagree or find situations or nitpick at these things, and that's definitely true, but there's enough of a consensus on these where they thought, okay, we can go with this. Another category was the real world connection, which is the name they gave to this, and that consists of these four states. And for these were the consensus expert-like responses.
What do the letters mean?
So, oh yeah, I should have said this. A means that agree is the consensus expert one, and D is disagree. Yeah. The general problem solving in general are these, and you'll probably notice there is some overlap. Some questions are belong to more than one category.
Are the questions presented in random order, or is there a particular logic behind it?
There is an order. So you can see that I've numbered these.
Right.
The survey statements are given in an order, and they're in an order where the categories are intermixed. I think some of the considerations when determining the order is that you don't want too many like agree or disagree in the same row, right? You don't want students to fall into a pattern.
Right.
But beyond that, I'm not aware of any particular thinking that went into, well, how are we going to order these?
Okay.
A good practice for giving the survey, though, and we'll touch on this later, is that if you, for the best comparability between what you're getting and other people are getting, you should give it in the same order because there's bound to be some influence on a student's state of mind when going through these. So you want to give them in the same order.
Okay.
And these are sort of the consensus expert responses, the two Ds for disagree and the A's for agree. There's a problem solving. The confidence category is these four statements.
So is the agreement sort of the dominant answer here?
In the first few, yes. Later on, there will be more statements that are in the disagree.
Because I'm wondering if the students reading all this, oh, that's what they want me to think. And then once they pick that up, they say, okay, I'll answer the way they think I should answer or something like that. I wonder if that sort of thing happens.
So that's definitely a concern, and that's actually been studied. They published a paper just a couple years after the initial one, and actually the initial one addresses this question as well, where when they gave this to students, they asked students to put what they thought and what they thought physicists would think. And students know very well what physicists think, but they disagree. And if you look at the pattern of what they thought their personal one was, and then what other classes where they just kind of asked the survey, it's pretty in line with that. So there's some confidence that students are actually answering how they believe and not what they think they should write. I think what also helps is that I've never heard of anyone giving this survey in a context where students feel like there's a right answer or that they will get more credit for answering the way the instructor wants or things like that. So with these are the sort of the expert responses. There's a problem-solving sophistication. Along with those.
Oh, here's a lot of D's here. Yeah.
Mhm. And I think the aim was to balance out the agrees and disagrees, although I don't think that was really done by category necessarily. The sense making and effort, I'll just show you the sort of the expert responses along with those. And just two more categories here. One is the conceptual understanding.
Oh,
These are all disagree.
okay. Yeah, I like the last one. Yeah.
And finally, the last category that they named applied conceptual understanding. And so, as Brian, as you mentioned in the chat, there are 42 questions on the survey. Let's see. I have numbers in my head, but somehow they don't seem correct. There are 36 of those 42 with sort of agree or disagree answers. There are also some uncategorized statements, so things that they have in there, but that don't really have a consensus agree or disagree. Also, as Brian, as you pointed out, they put a question in there that says we use this question to discard the surveys of people who are not paying attention. Answer choice D for this one. And so students are supposed to say choice D. I can't remember if that's agree or disagree. And that is a way to sort out if students are just sort of answering the questions without really thinking about them. Okay. Okay, in terms of administering the survey, let's see, Anthony, you had a comment about number 8. Okay, which one is that? This one. Number 8 is interesting, but that's yeah. So
I mean,
go ahead.
oh, I was just gonna say, like, I get why that, like, there's a disagreement about that, but I think, like, at least at some level, I think that's at least part of the process. Maybe not as stark, but like, but if I guess if that's like the only like thing that goes along with it, then I can see that's kind of it.
Mhm. Okay, so administering this. So if this is a thing that you are interested in doing, this survey has the advantage of being relatively short to give. I mean, there are 42 statements, but students can pretty quickly decide whether they agree or disagree with the thing. Um, some of the guidelines that they have. Usually, you want to do kind of a pre and a post administration because the idea is to see maybe what effect your course has on students. Are you helping them to become more expert-like in attitudes or not? If that's a thing that you're interested in. So typically, you would give them this survey once near the beginning of the course and then once near the end of the course. You typically want to frame the survey as helping you to evaluate the course because you don't want students to be anxious about, kind of like you were saying, Kareem, do I have to give the right answer? Does it make me look better to give the right answer? If students feel like, oh, this is to help the instructor fine tune the course or think or evaluate what they're doing, it can relieve students' anxiety that it's not about them. In class versus outside class. I think many people do give the survey outside of class. So they have it on a website where students can go to and students respond to it. Also, some people do give it in class. I guess I would say that my personal bias is I try to give it in class. And the reason for that is because then it's more likely that students do it and they think about the statements. Because they're in class, they don't really have anything better to do if they're sitting there. And so they do that. I tend to give this at the same time as some other surveys, like I might do the force concept inventory for mechanics class or one of the electricity and magnetism surveys for an E&M physics class. So it's all kind of together. And yeah, I guess this attitude of mine is brought over from Minnesota because there they have for decades they've been assessing their physics classes in some fairly standard ways, and they've always done them in class just to kind of make sure that as much as possible students are taking them seriously and they can and you get the maximum participation because students are there. Okay. If it's outside of class, you can definitely assign like some extra credit or homework credit or something like that. But that's definitely a choice. The guidelines recommend 8 to 10 minutes, which to me seems awful fast. I would say, especially if you have students for whom English is not their first language, you want to think about possibly giving them more time. Okay. I personally don't know what a good amount of time would be because whenever I do this, it is mixed in with other things. But I would probably go at least 20 minutes where I am, which is a Hispanic serving institution, I do have students who regularly tell me that English is not their first language, so I definitely want to give them enough time to think about it. A great resource as for this and many things is the Fizport site. If you're not familiar with it, here's the main URL, www.fizport.org. They have a lot of information about different teaching, curriculum, assessment things, and they have a whole thing about guidelines for giving surveys. And thanks for Chris for posting that in the chat. Let's see, Brian, you put a comment in there about in the past there's a trend that post scores were typically lower than pre scores. And is that still the case? That is, to the best of my knowledge, that is still the case. Yes. And we'll talk about some of the speculated reasons for that. So that's some of the information about the survey and giving the survey. In terms of analyzing the results, let me talk about a couple ways that you could go through to analyze results and what kind of information you can get from it. Okay, so as with any kind of standardized thing, what you should be prepared to do is prepare your data. So you're going to get a lot of student responses. If you're doing this online, one of the big advantages of giving the survey online is that it goes right into a computer and it's easier to deal with the data. Giving it in class, as I do, I have students put their answers on a Scantron, run the Scantrons through a program that puts them all in an Excel file. And so that helps me with my data preparation. But that is a thing that will take some time. And as with all of these sort of pre-post things, ideally, what you would like to do is create a matched set of pre and post data. So you'll need some kind of identification so you know which students took both the pre and post, so you can include just them in your analysis. And I mentioned there one of the questions, if people didn't respond with option D to question number 31, typically you should discard their survey. Either they weren't doing it seriously, or you can't be sure that they understood the statements well enough. There are two main avenues that I am aware of for analyzing the data that you get. One is the Fizzport Data Explorer. So on that Fizzport site, they have a way where you can upload your data, and they have a number of confidentiality safeguards because you don't want your students' data being sprayed all over the place. And then there are a number of ways in which they can analyze the data for you. And a little bit later, I'll show you what some of those look like. There's also an Excel analysis sheet that's on the Fizzport site. And you can download that sheet and analyze your data in it. Now, I have to say that that sheet comes with, it's a workbook. It has many sheets in it. And one of the sheets has instructions. And at least for me, those instructions do not work. And I remember that like 15 years ago or 10 years ago, when I was doing a lot of this, I also got a hold of an Excel sheet, and it had the same instructions that also didn't work. As I was preparing this presentation, I remembered back to when I was doing this a long time ago. Oh yeah, those instructions don't work. So I'll try to give you instructions that do work in case you want to do that, and we can see why. So let me just show you some, I don't know, typical results that I got. So what I have here, and this is a screenshot. This is a piece from the Excel sheet, and I'll show you the full sheet later and kind of what are the kinds of things. But there's one sheet in the Excel workbook where they summarize all the results from your class along these categories. So what do we have here? This data comes from the introductory calc-based mechanics class that I teach here at Santa Rosa Junior College. And I have combined 3 semesters together. So fall 23, spring 24, and fall 25. And here we can see that there's about 203 people that I picked up who responded both on the pre-test and on the post-test, the pre and post survey. So these are students for whom I had matched data. Okay. So what are these? The last 8 are abbreviations for the categories: personal interest, real world connection, and so on. Up here, all is all of the statements for which there is a consensus, agree or disagree by experts. And then down here, I believe, from what I remember, this is all 26 questions that are in these categories. But somehow, now that I think about that, that seems wrong. So I'll need to go back and check that, because it feels like there's a lot more than 26 questions in these categories. So either that's a typo or something's weird there. And the way this is broken down is it looks at the percentage of favorable and unfavorable. So favorable are the ones where students pick the choice that agrees with the expert consensus. And unfavorable is if they did the opposite. And this first column here is the pre-data. So for example, if we look overall with all the questions, 67% of the responses to those questions were in the favorable direction, and 13.2 were in the unfavorable direction. There's also a neutral category, right? It's all of these students respond with on a 5-point scale, where 3 is they don't have an opinion. And so the reason these don't add up to 100 is because there's some fraction of neutral responses. So these are the results for the pre, and then broken down by category is sort of the percentage of favorable and unfavorable responses for each of those. This next column is the post. So if you survey them afterwards, what does that look like? And then the shift just does the math for you. What's the difference between those two? In this last column, they give a standard error for that shift. And then if any of your shifts are more than twice the standard error, then they will just repeat them here. So this pulls out things that where the change in the percentage of students responding one way or the other is more than twice the standard error. And that approximately corresponds to sort of a 95% confidence interval if you're doing the statistics. And so, as Brian was saying, there's this thing where, yeah, there's seems like there is in the past, there was this thing about what was I going to say? Where if you don't really pay attention to it, or most intro courses, the results kind of deteriorate a bit. And as you can see here, in terms of the shift, it's not big. But where there are shifts, some of them okay, some of them, not so great. And let's see, there are a bunch of comments here. 203 seems like a lot for 3 semesters. Okay, so some context here. This calc-based mechanics course, we enroll about 80 to 90 students per semester. So this would represent something like 80% of the students. So actually, it's not a lot for the number of students that we have here. And yeah, so we have the way we divide up our classes. Each semester, we have it's kind of small enough so that a single faculty member can do all of the sections of this intro calc-based mechanics class. So these are the 3 semesters in the most recent past where I was teaching the class. People do what they want. I think I'm the only one here doing this survey, so these are just all of my students in those 3 semesters. Okay, so just to clarify some of the things going on in the chat. Yeah, so that's that. So this is a kind of thing that you can see. The Excel sheet has, at some point in the last 10 years, been updated where it will do some breakdowns for you. For example, it will take this, and if you feed it data on students' gender, then it will break it down for you. So this is the same data as before, broken down by women and men. And the students who did not identify as women or men are a really small number, so that was not in here. And so there are, if you're looking for, are there gender differences, then it seems that there's some difference, although in my classes, probably in yours to some extent, I don't know whether it is as sort of extreme as mine. The number of males in the class, it's sort of, at least the responses that I have, is kind of a 3-to-1 ratio. And one thing that I realized when putting this presentation together, when I did it, I had this pile of data, this class survey data. And I thought, oh, well, this is a good motivation for me to go ahead and analyze this, because it was just kind of sitting around. So I analyzed it. And when I look at these, there's kind of there's a difference, right? If I look at the women results, then all the shifts, okay, with the exception of real world connection and sense making and effort. All the favorable shifts are positive, and all the unfavorable shifts are negative. Well, okay, with the exception of those two categories. If I go to the male side, it's the other way around. So something's going on. I don't know. But this is the kind of information you can get from this analysis. Okay. And then if you have more time or you're research oriented, you can go and try to look at that. Okay. Just as a contrast, so this is for a typical introductory calculus-based physics class. When I used to teach that class for pre-service elementary teachers at Minnesota, that was, of course, a very different class. And in that class, I was using the physics by inquiry curriculum. So that's a very hands-on, lab-based kind of class. The curriculum was designed by the folks at the University of Washington. It's been around for a long time. I really like it for pre-service elementary teachers. And the results that I got from the pre-service elementary teachers are these. And I think the curriculum definitely plays a large part, because if you look at these, the shifts are generally large and they're generally quite positive. And I guess this is encouraging, because if I can help people who are going to be elementary teachers have more expert-like attitudes about physics, I think that's a good thing. Yeah, so these are University of Minnesota students. The 409 is because I compiled a lot of semesters together. Yeah, if you have a lab-based class, then you don't have that many students in at once. So let me show you a couple of other things in terms of what you can get from the analysis. All right. So let me show you what you can get from the Phys-Port site. So to do that, I need to find Zoom, and I need to share the right thing. What if I just share this? Okay, so let's try this. So here I've brought up the Phys-Port site, and I've logged in, and this data that's being shown is the same. It's for my calculus-based intro mechanics class. So I've put that in, and the first thing it gives me is this histogram for my class. So I guess my class is the heavy blue line here. And then it can also compare my results with national averages. So other people who are using the Phys-Port site, two-year colleges in the US, or all colleges. And you can see it's very close to zero. Okay, so my average shift was 0.4, but the standard deviation is huge. So basically that's zero. If you look at the others, it's around the same thing. One thing that I did get, let's see. So I can also split by, so for example, I can have Phys-Port split by gender. So here's the male shift and the female. So you can take a look at that. That was something that the Excel sheet would also give to you. I happen to feed Phys-Port the final course grades of students. That was not something that the Excel sheet is set up to do. But if I split it by course grade, here's kind of an interesting, although not necessarily unexpected result. So the students who wound up with an A in the class, if I put on them, the mean shift is 4%. So sort of a 4% shift in the positive direction. You can see the standard error of the mean is plus or minus 2% there. If I look at the students who wound up with a B, the average shift is a positive 3%. If I go to the C students, it's a negative 2. And if I go to the students who earned a D, it's negative 20. But there are not many of those. That's a small n. So here, these are other breakdowns that the Fizzport site can give you. You can split by all of these different kinds of things if you tell Fizzport some of the characteristics of your students. And finally, if we look back at the Excel sheet, it's kind of a monster. There are lots of sheets. There's a sheet where you put in all of your data. So there's all the student data. But then it kind of nicely gives you this overview. And these are sort of the tables that I was showing you pieces of before. This is for my calculus-based class. This is overall female breakdown, male breakdown. Another thing it can give you, if you look down here, questions by category. So on that sheet, it looks at, let me move this. Each of the individual questions, pre and post percentages, including the neutrals, and what the shift was, and whether these are expert or novice-like shifts. In what direction is the shift? And then they're broken down by categories, so you can see on individual questions, where did things go up, where did things go down? And so just a whole bunch of information. And then at the very end, they'll just do all the survey questions in order. So lots of pretty detailed information here. So those are things you can get out of that. Also on the general overview, if you don't like the numbers, you can also, they also plot these graphs here. Let's see, I can make this a little bigger. We can focus in on this graph. So this shows the pre and post for all students. This one, for example, real world connection, the pre is the blue diamond and the post is the red diamond. And so that's this shift here. So here's the pre, where percent favorable, here's the post. So this shifted down and to the right, so the favorable percentage is going down, the unfavorable percentage is going up. Okay. All right. In terms of final thoughts, let me go ahead and stop that share. In terms of final thoughts, I would say if you're interested in this, the place to start is to go on Fizzport, and for all of their assessments, they have these very nice implementation guides that you can take a look at. Those tell you all of these things and more, and also give you references. So if you want to look up the original references. So for example, the original paper about the class, and also that one, let's see, what was the title? The title was, the title of the paper was Students Know What Physicists Believe, But They Don't Agree, a study using the class survey. So that was the one where they had more results about, yeah, students know what they're supposed to say, but they're like, no, I don't believe that. So let me just go ahead and end there and throw it open to discussion.
Kareem, did you want to go ahead and share the data?
Oh yeah, Kareem, yeah.
Well, it's just a very brief summary of what we had. So we've done this at Santa Fe for the past, well, we started in fall 2024 as part of our quality enhancement plan for the college. And so each department was trying to do different things. And so for physics, we kind of agreed that we wanted to do two separate things. On one hand, a content survey. So we do FCI and CSAM, and this semester we're trying to BIMA. And then we also wanted to have something like a CLAS and or class. And so we picked that one and we've done it. And so we were looking at whether we are able to move things one way or the other. So this is a very brief summary of what we had. So this is the favorable, I think, average up. This I picked up from my colleague Brian Lee with the data. So I have a a couple of things I'm not sure about, but I guess this is a very summary of the data. And so we've got a very, very tiny shift in some classes. This one did have a shift. I mean, this is the analysis that came from FISPORT. So that's the nice thing, is that FISPORT does provide this analysis. So even if you're not totally familiar with the procedure, once you upload your data, you can get some feedback from FISPORT, which I think is a very nice feature. And also, we also wanted to be sort of contributing to the database from two-year colleges, because one of the themes we've had around here is that there's not enough data about two-year colleges. So adding to what's on FISPORT may help in the future. I'm not sure what percentage of the data is from two-year colleges at this point on FISPORT, at least within this particular assessment. But so this was a class that's a very basic trig-based class, first semester mechanics class. Then, Anthony, if you can go to the next slide, it's kind of the same thing. And this is a calc-based class. So this one didn't have much of a shift from one semester to another. And we also were happy to see that at least our data is within the national average kind of range. So that was as a first attempt, we were happy to see that. And then we're continuing working on that. So we're going to see if we can do anything about this particular thing, which is actually one of the questions we're going to ask you. Are there any strategies that are known to be able to move this kind of thing? I know it's a hard question for a lot of time, but what do you think? And you can go ahead for the last one, Anthony. There's just a couple, so that's pretty much similar to what we had before. Okay, so anyway, it was just a little data point I wanted to add to the discussion, and in case other people wanted to see some from a different college. And this is, of course, from people who are not experienced with CLAS, so none of us had ever used it before. And so that was the first attempt for everyone.
Yeah, what I'm aware of is that the general consensus is that unless you pay attention to this, unless this becomes a goal of your class, nothing really happens, or you get slight degrades in the attitudes. As to what those are, well, let's see. What's been published in the past, I know the people who do modeling. There was some stuff published from them out of, I think, maybe Florida International University. And I think those show definite positive shifts. And, because if you know about the modeling curriculum, they pay a lot of attention to this is kind of the spirit and this is what we're doing. So that and things like physics by inquiry, probably the next gen physics for everyday thinking, those kinds of curricula that really hit those kinds of things about, well, what is physics? And they don't have as much to do with, well, we got to learn all these different concepts. They have more time to do that. I think those are the things that work. Yeah, Anthony.
Well, I had a question. I guess first of all, just before we reach the 3 o'clock hour, I'll just quickly. I'll have my question soon, but I'll just quickly just share the QR code for the participant feedback, just to make sure I get to that, and then I'll also put in the chat the link to that feedback survey. Which I guess I was too slow. Chris also added it as well. But yeah, I wanted to get that, make sure I got taken care of. I also had a question. I noticed, what you showed in the FISPORT site. Does it also divide by like tier, or does it separate by tier college the different categories of questions? Because I'm like, in terms of like, what did you say? There was like the real world connections, and I think the personal, I forget what the first
Personal
category was.
interest. Mhm.
Personal interest. And I'm wondering that because, I was looking through the class, and then, the questions seem pretty general, right? They would apply it to most people, somewhat the same. But I can see, like, for tier colleges, right, when you talk about everyday life, that everyday life is kind of different for a tier college student than say like someone at a 4-year college, right? We have like different resources, different constraints. So like when you ask a student to like reflect on their everyday life, I can see the context might have color the way they respond. So Yeah, do you know like if there's any been like research or study, or if you can see the FISPORT, like how like 2-year college students versus 4-year college students that maybe respond to that category of questions?
Um, I have not played around with the Fizzport site as much. Kareem, do you know?
No, no, I haven't myself, so I don't know. I can't answer that question.
So that I don't know. Uh, let's see. Oh, Chris, maybe I'll just point this at you. It looks like Michael had a question in the chat. I'll leave that to you
Yep,
if that's the
I'm
thing.
on it, Michael. No
Okay.
worries.
Okay. And yeah, but this is I think one of the things that Kareem you've talked about as well in terms of the physics education research has been really sort of R1 centric so far. And you know, all those student interviews about how they interpret the questions and the reliability have been with students who are at like the University of Colorado Boulder or at these four-year research universities. And as far as I know, no one has replicated that at with two-year college students. So that's definitely, you know, a consideration.
Mhm. So even in terms of a much simpler thing to do, which is essentially running the assessment over multiple semesters and providing an analysis of the data, is there value in doing this for two-year colleges as a publication? Or is this something that would be useful to the field? You know, because there's been a lot of publications about this. Most of them seem to be for four-year colleges. If someone from a two-year college were to do this, would that be of any value beyond their own personal campus?
I feel like it should be of value because that data isn't out there. And we would like to know to what extent these assessment instruments that were developed in one context, how applicable they are to another. So I definitely think, yeah, if a bunch of people got some data together, that could be the basis for a publication. Uh, I think one of the reasons I got asked to do this was a paper that I had been involved with about 10 years ago, which was in a similar vein. There was a bunch of us who'd used the class survey in a type of course that had not been published about. So these were sort of gen ed classes, um, not the standard physics sequence. And so a bunch of us got together and said, hey, here's the results that we got, and that was the paper that was published. So I think two-year colleges, definitely. Yeah, we all know the the number of students who will take physics at two-year colleges. It's a huge number. And so I think that's definitely valuable to have that data.
Okay. Because one of the themes that has emerged over the past, now was it 4 years from what we've been doing in optics, is the fact that yes, there is a lot that's known about four-year colleges, not so much from two-year colleges. And maybe the lesson there is that maybe we shouldn't wait for the four-year colleges to actually do it. Maybe to some extent, whatever the two-year colleges can do, there are certain limitations that we have in terms of doing some of the research, but at least in gathering data and publishing the data, I think that's an effort that we could maybe make and add to what's out there, and maybe that will help, or at least provide evidence for those researchers that maybe they ought to think differently when they think about two-year colleges, and not assume that it's, well, all students are all the same and basically we don't need to have a separate study for two-year colleges. So maybe that would be a useful bit of evidence if we could do it.
Yeah. I think in some ways it parallels the study of medicine, where a lot of the clinical trials are with certain groups. And so the applicability of those same medicines on other groups may not be the same.
Yeah. And maybe we should just keep bringing awareness of these instruments and have more and more people join in at least the effort of collecting and putting it somewhere at FISPORT, and then someone eventually will go grab it and do something with it.
Yeah.
thanks, Leon, for sharing. Yeah, that was really great. And yeah, thanks, Kareem, also for quickly sharing your context. Yeah, thanks everyone for attending, and yeah, look up for hopefully you get to attend the next optics event.